So here I mentioned again cleaning and shaping. I have to understand what's cleaning and shaping. Cleaning is the removal of the all potentially pathogenic content from the root canal system. Okay. During shaping, the organic substrate, microflora, bacteria, bacterial byproduct, food debris, caries, denticle, pulpstone, even if there is a previous root canal filling for retreatment cases, all should be removed, i.e., the removal of the smear layer. Shaping means formation of a specific cavity form with 5 designs of objectives. Cleaning can be done by irrigation after shaping, okay, while shaping is done by instruments. How many phases do we have? The 5 phases are how to negotiate to the canal, i.e., the excess opening. Patency filling. You will open the way for the filling. Coronal pre-enlargement. If you remember, we mentioned that by using the burrs so that the wall of the canal should be continue with the wall of the cavity of the excess opening. There should be no steps to interfere with the free movement of the instrument. And we use the guts gilden sometime, we use bears. Third, a working length measurement, which means that we never enlarge or extend. We have a certain limit. Once we negotiate the canal, think about working length measurements. And then you can continue your instrumentation and shaping. And in shaping, there are techniques, and you know them, okay? The root canal working length is important too. Not to be too wide, otherwise it will affect the tooth structure. It will and not support it. For cleaning and shaping, we have objectives, and these are the mechanical objectives, biological objectives, technical objectives, and some clinical issues. For the mechanical objectives, which means the root canal surfaces are mechanically prepared. When we prepare the root canal surfaces, we have to be precise, because any skipping for the number of dreamers, any misusing, we might end to deviations, zipping, perforations. These things should be absent. Okay, all of these, any deviation or any zipping, perforation, okay, which means that I am not reaching the end. Okay, so these will leave part of the pulp tissue inside the canal, or part of the area of the canal is not accessible for any disinfection. So how I will clean, and cleaning is my aim. Again, here we should remember that during cleaning, the wall of the root canal is about 1 millimeter width. We should not increase the size, okay, to have a very weak wall to the root canal. The number which appears here, 0.03, less if the root canal was less than 0.3, it will break. But if it was larger or about to be 0.3 in diameter, I mean thickness, it will be fine. I think I have some problem, I have to fix it. Anyhow, for the biological objectives, we should always remember that the canal should be prepared uniformly and continuously taper. That's important. It will facilitate the removal of the infected pulp and dentine. It will create a good space to deliver the irrigant fluid, passively into the canal with the syringe and needle. And this picture can show you that the needle tip of the irrigant should reach 1 millimeter shorter than the apical foramen to ensure that the full length of the canal is irrigated. Try always to be careful not to push the necrotic debris periapically. Otherwise, you will have a periapical problems and abscess. Clean and then irrigate. Clean and then irrigate. The root canal space is undefined. You cannot put certain limit. Okay? So it is a dark space, a warm space, okay, because it's with the body temperature and fluid, it's mostly the body fluid, which means it provides good nutrient for any microbial proliferation. I always tell my patients, especially when I do instrumentation, sometimes accidentally it happens that the patient, after the first visit, he will come back with some pain or an abscess, okay, some infection in the periapical area. So I always tell him, okay, why not? Because you left your tooth in such a way that there was a good food for the bacteria. They were preparing good lunch every day. And now we disturb them. So you should expect some revolution there. And that is the truth. So once the root canal space is infected, the endodontic microbiota exists in fluid phase or in dense bacterial aggregate or coagule. They adhere to the root canal wall, as you can see in the picture nearby. They will form multi-layer community that resembles biofilm, and they call it smear layer 2. Every tooth has a unique anatomy. Okay, there may be some accessory canal. You should expect fins, isthmus, branches, and other apparent forms. For the technical objectives, although the continuous taper that resembles, or we always try to resemble, the original shape and curvature of the canal, though it is an accepted goal, but the final apical preparation size remains a much disputed entity in root canal therapy, as does the final taper of the preparation. So the canal axis, the position of the canal axis should maintain in the center of the root. The foramen we should keep the foramen in its original position and should maintain and should not be enlarged. You can see here the deviation, okay, that happened in one of the roots. Okay, there is a transformation of the root canal. I mean the foramen, and that is wrong. That's a failure. Yes. So for long-term survival of a tooth, okay, we should think about larger canal preparation. It will cause, or it will compromise the delicate anatomy of the apical foramen, and then will compromise the ability to seal the apical foramen. Sealing the canal at the apical third is number one. It has a priority. Then again, a larger canal preparation, we might be at the risk of perforation, weakness of the dentine. So try to avoid a larger canal preparation. Now, we finished even the technical issue. For the canal size and the removal of the smear layer, it's for your information. I will tell you that there are two schools. One school says that I can keep the smear layer, okay, isolating the material, the sealer I am using, so not to be affecting through the weak canal dentine, the canal wall, which is the dentine, not to affect the periodontal ligament. Other school, so it's better to keep it but sterilize it. Other school says that it's better to mechanically remove it and enlarge the size of the canal. So there are two schools, but it's very important to sterilize inside the canal. That's why there are many systems for sterilization, using EDTA, using hydrogen peroxide. Hydrogen peroxide, it was used, I don't know if there are still people using it, but mostly is the EDTA, then the sodium hypochlorite with 2.5% till 5% is acceptable, and then we have the chlorhexidine. It's a good disinfectant too, but and the nice thing with the chlorhexidine that it stays, the disinfection of the chlorhexidine can stay for 72 hours inside the canal. Anyhow, there are many systems. You have to look for them and read about them because we have no time. For the endodontic instrument, there are many type of endodontic instrument, and always remember that when you go to buy, you should know what is the type of the endodontic instrument you are using. There are some endodontic instruments does not perforate the root canal. They have only, or they are designed in a way to enlarge the canal. Some are designed in a way to clean or extract the pulp out of the canal, like the barbed brooch. Okay. Some are designed to be used in file motion, like the headstrong files, though their designs makes them weak and easy to break. Mostly we use the files. And even files, as you know, we have types: K file, H file. Anyhow, the most popular used is the K file. The K file and the NiTi rotary instrument. NiTi means nickel titanium. They have special designs principle. We will discuss them. Okay. Barbed brooch also, but it's all having these spine-like that capture and stuck to the pulp tissue to facilitate its removal. But never ever think that you should introduce the barbed brooch first. Okay, you should enlarge the canal enough, then you can introduce the barbed brooch. For the instruments, there are things we should know about because they really affect their work. We have to know the tip. Is it a cutting tip or no? We have to know about the diameter. We have to know the cross section. Okay, so all of these are important in each instrument. I know that you have taken the shaping and cleaning in fourth year in a classical way, so I have to give you something different. So for a root canal preparation, an instrument tip has two main functions: to guide the file through the canal and to aid the file in penetrating deeper into the canal. The clinician unfamiliar with the tip design, that is normal, in particular of the rotary instruments, may do either of the following: the tip in any rotary instrument, or even for the fiber, and I mean for the file. Transport the canal if the tip is capable of enlarging and is used too long in one position in a curved canal. Encounter excessive torsion and break the file if the non-cutting tip is forced into the canal with a smaller diameter than the tip. So let us talk here. Once you start working with the canal, even if it is rotary instrument or no, I never start introducing the rotary instrument first. I always start with a small diameter stainless steel instrument. Why? Because they are flexible. It's better to be sure that the canal is accessible to the tip. For me, I reach size 20, 25, then I start with the rotary instrument. Okay, some they are using number 10. Okay, and then to be sure that, why? Because I don't want to make a perforation in a curved canal. The larger diameter, they are mostly not flexible. They don't go with the anatomy of the canal. So I do this. Second, to be sure that I will not have breakage inside the canal. Because sometimes if you are using the non-cutting tips, okay, and you force it inside the canal, and the canal is already having a small diameter, there, especially with the rotary instrument, it is, you don't have a tactile sensation when you work with a rotary instrument. Maybe the diameter, not of the tip, maybe in D3 or D4 further than the tip, it may stuck with at the wall of the canal, and you are still forcing the rotary instrument inside the canal. Then you will end up with a breaking, which is torsion break. There is torsion fatigue and cyclic fatigue. These two fatigues are important because if you don't count them very well, you will end up with fracture of instrument inside the canal. So in rotary instrument, two things you have to take care of: not to transport the canal and not to break the instrument. These for me are tips. And remember, if you are using the hand instrument, check the tips of the instrument. Look uh, the K-reamer tip, the file tip, okay, the head strum tip, rasp, pulp extractor, barber brush, the canal filler, because we are using it to introduce the sealer inside the canal. Really, the K file, it has a pyramid tip. I know the shape. If I bring a knife and cut the file, the shape will be rectangular. I know. But just imagine the tip of the file with it. So it is really wide in shape. These things are important. The propensity to transport the canal. We should check the cutting ability of the instrument and the rigidity of my instrument. That's why I said when I start, and never skip a number of the instrument, because the number means the diameter. 8 diameter means 0.008 from the millim. Okay, am I clear? The cutting ability, I mean the tip. Okay. The rigidity, for example, in stainless steel, they are flexible till number 25 or 20. 20, yes. 25, it's doubtful. With the night tie, they are more flexible, especially the twisted type. Why they are flexible? Because they have that ability, okay, to be changed with the temperature, okay, and the pressure. The cutting ability depend on the angle and rigidity of the leading edge, proximity of the flute to its actual tip end. These two things. What? The tip of the K file, as I told you, is just it's a pyramid. Non-cutting. It has a non-cutting bad tip and a partial cutting and a cutting. So this pyramids, as it shows here in the picture, the first picture at the top, you can see that the tip is, for example, if it is pointing to me, then that circle is the canal wall. You can see at the tip A, it's a cutting end, and B is a non-cutting end. Okay, mostly they do it so they to increase the life of the file, because if I imagine if you have four angles, all of them are in contact with the wall, so there will be some cyclic fatigue. It will break easy. So this is it is something like relieving. The bad tip are created by grinding and smoothing the apical end of the instrument. Tip modification was introduced. There are more modification with the flex R file. It is fully manufactured by grinding so that the transitional angle were smoothed laterally between the tip and the instrument working part. You can see here, this is here, it is not the tip, it is not like a needle tip. I mean, it is not sharp. Okay, the flexar file, it is not a cutting end. They grind the tip. Here it's more clear. Comparison of the flute geometry and the tip configuration of the hand file and the night-tie rotary instrument, which is in B. You can see here that the K file with a sharp cutting edge, like here in the arrow, you can see the sharp cutting edge, and I will explain that in details. And you can see how they grind the tip. In rotary file with a rounded and non-cutting tip, okay, smooth, you can see that the smooth transition of the guiding radial lands, these are the radial lands. This is, we call them radial lands. And you can see the rounded tip. Why? To have safe cutting, not to cause perforation, for example. For night-tie rotary files, mostly the tip is rounded and non-cutting. Why? To prevent any error. Because I told you that we don't have the tactile sensation. So we call them safe cutting end. But in some of the rotary instruments, the tip is sharp. Why? Because I use it for removal of the guttapercha. These are the retreatment instruments. In the previous, here is the land. Okay. The land formation result by grinding wheel is left at the handle end. These are that the periphery are shorter. There is some grinding in the periphery. Okay, why they are there? Because we don't want to have screwing in of the fiber. It screws in and stucks. This is a relief for the fiber. Okay, it supports the cutting edge, limits the depth of the cut, and reduces the propagation of micro cracks on its circumference. Maintain the file in the center of the root canal. So check these three wings. It's like the fan we have all in our houses. Okay, check if these wings end were straight. That will affect, there will be some screw in of the file inside the dentine, and I'm still working and screwing it inside, so it will stuck and break. Okay, so there is some relief here at the periphery of each wing. We call them and to reduce the frictional resistance. So here again, this picture can show you that some of the surface area of the land that rotates against the canal wall may be reduced to create a relief. The angle of the cutting edge forms with the long axis of the file is called a helical angle. Okay, they cut them in an helical angle. Now, how many types of angles do we have in each file? We have many. Check here. Again, inside the file, we have something called rack angle. This angle is formed. It's either could be positive, could be negative, and could be natural. Depend on the function of the file. Okay. This is a file. If I cut it with a knife, in a direction perpendicular to the long axis of the file. So check the angles. You remember we were talking about the cutting angles, the cutting edges. So either they have a negative rack angle or a neutral rack angle or a positive rack angle. For each one there is a function. What are the pitches? The pitch is here, as it shows. It's clear distance between a point on a leading edge and the corresponding point on the adjacent leading edge. These distance, they might be equal or they might be variable. Again, depend on the type. See, here we can check that a lateral view showing you the detail of the helical angle, and the P is the pitch and the presence of the guiding area, and the radial land. Here you can see that these cuttings are not sharp like a knife. There is a radial land. There is some grading there. Okay. And here also, this is also ground working part of the instrument, showing you this U shape. This is the dimension, and these are the U shape excavation. As I said, if I cut this longitudinally with the knife, I will have this. This U shape resembles these grooves. Okay, these grooves that hold the soft tissue or the tissue I'm removing, okay, during my. The third thing I have to take care, I said the tip, I said the longitudinal configuration, and the third thing is the tip. Is it a taper? Or how taper it is? Really, there are different tapering for the root canal. For years we were using the 2% tapering for years, and you know how to calculate the tapering, okay, by dividing the diameter, for example D1 over D16 over D1, you will have, okay, and mostly it is mentioned by a percentage. We have tapering 2%, we have 4%, we have 6%, depends. Okay, some of them, the hand instrument, mostly they have a constant tapering. The rotary instrument depend on the function and according to the manufacturer. Nowadays, when I was graduated, there was nothing like that. But nowadays, whenever they work with a specially curved canal, the presenter would tell you that he started with that number file, okay, but maybe it's F1 or F2, or he will tell you the number of the file, and then he will mention the tapering. Why there are different tapering? Because again, we are trying to mimic the tapering of the root canal system. For example, this is an iris system. You can check the difference in the diameter. They have R1, which resembles number 15 with a stainless steel instrument, but check the tapering is 6%. We have R2, 25, the tapering is 4%, and we have R3, which is 30 as a number, as a diameter, and then the tapering is 4%. Now, I will tell you where I use such system. When I have a narrow canal and I find that it is too difficult to introduce 15, it is tight, so I start to introduce 15 with the diameter, with the tapering of 6%. Okay, and then after that I have a 25 with a tapering of 4%. Check, which means that really 25 as a diameter is larger than 50, but again the tapering is less. In number 50 I got the funneling shape where the let us say D16, for example, is much larger than D1. Then I follow it with number 25. The tapering is 4%, which means that D16 is slightly having nearby diameter to the D1. Till I reach the end, I will have some difficulty at the tip, but not at the coronal part of the root canal. Then I follow it with R3. The diameter is 40. The tapering is 4%. By when I finish with a number 30, which means R3, then the canal will be prepared as if I'm preparing number 30 stainless steel or any other normal instrument that has a constant tapering, which means I start to introduce a small diameter instrument to the apex, but the tapering is more. So in the coronal part of the root canal and the middle part of the root canal, it will be wider. Then I introduce a larger diameter inside the canal. The tapering is less, so for the apical and the middle third, the enlargement will be less than the enlargement in the apical position. I hope I'm clear. This is mostly used in tight canals. So the current developments in the instruments, they include variations in the helical area, in the pitches. Sometimes you will find the pitches are very near each other in the apical part to increase the cutting in the apical part, and then after a certain distance it will start again. I mean, the relief will be in this way and taper along the cutting portion, and we will have variation in the alloys. Like first it was just stainless steel, then nowadays they are using the nickel, the nitide, the nickel titanium, because they are flexible. Then the rational speed, because it will really affect the cutting behavior. We were using our hand. Nowadays we are using the machines. Let us talk about the nickel titanium a little bit. Nickel titanium, definitely I have a full lecture about them, but they are in details more. Maybe Yes, they are a little bit advanced. So what is the elastic limit in the nickel titanium? We will talk about, and how the nickel titanium are flexible. What is elastic limit? Is the maximum stress that can be applied to a metal without producing permanent deformation. In dental material, the first chapter you take is the stress over strain, and there is a curve where the material was elastic at a certain limit. I mean, like for example, an impression material. As an example, when it is a dough, you can play with it. It's elastic. When it sets, it becomes plastic. Uh, most of the materials we are using, like the laptop in front of me now, it's plastic. But definitely, when the material was made, it was elastic, and now I am using it as a plastic. So elastic limit is a point where the material was elastic after certain stress. The deformation cannot be relieved. And I hope you remember. If you don't remember this lecture, the mechanical property of the materials, try to go back and remember. So an application of external force, definitely it will cause some internal stress inside each material that cause deformation. Like a balloon is full of air. If you press it from outside, okay, there will be a change in its color, its shape. And then when you release the stress of your hand, it will return to normal. So it has a high elastic limit. But if you once you press it breaks, it explodes. So its elastic limit is less. So if the stress are not too much, the metal will return to its original dimension on removal of the stress. So this is elastic limit. The stress is the force acting across a unit area in a solid material. Stress is a quotient of a force divided by the area. So this is the elastic limit, force over an area. Now this is just the stress, it's force over an area, which means force, it is what your hand is doing. It's pressing on the balloon. The area is the area where there was a deformity. What is the strain? Is amount of deformation in the metal. Maybe there will be a change in length, maybe. So this is a deformity. How you know that the amount of change? By dividing the change over the original length. Strain has no unit. So the elastic deformation here, again, check the hand how it presses. Okay, so when the ball is there, if you press on, it will change, and then if you release your hand, it will go back. The stainless steel have the same thing. We call it a shape memory. It has two phases. It's like an accordion. You know the accordion, that musical instrument. You can press on it and it will be very short, and you can strain it. It will be very long. You can push the two parts away. But when the musician leave it as it is, it does not play on it, it will return to its shape. So this is, we call it a shape memory. Does everything have a shape memory? No. It is a property of an alloy to return to its original shape when heated. For example, so this is a memory shape of the nickel titanium.